Mr. Ward's class,
Stop getting
Wednesday,
Yeah.
March 7th.
No. Okay.
You should have that being American. Mr. Moore's class.
Be a real YouTuber. Like, subscribe, click the links down below, and watch another video.
But we should get merchandise. Mr. Ward merch.
Oh.
Yes!
No. My son said it the other day. He's been watching YouTube, like, because he liked watching his, like, these little videos and stuff. And he said it the other day. He's like, subscribe, and click the links down below. You're done with your YouTube from now on. You're done. You're done. You're cut off. You don't get to watch that anymore.
You gotta get your mustache Mondays shirts. That'd be good. We could honestly make one famous.
Alright, hey, here we go. Today. Okay, today. Here's what we have to focus on right here. Okay, we have to focus on these three parts right here of my formula. These are the ones that this section, 5.2, is all based on. It's based on sum and differences, adding and subtracting. I introed what these were on Monday. You know, how to use them if you want to find weird, obscure angles. The goal today is to do another example of that, have you try out one or two, and then show you the other realm of what we can use it for. Because some people are like, okay, we can find random weird angles, but you can also simplify problems down that look more complicated than they are. For instance, we'll start here. I'm going to start with like one of those instances where maybe you have a very difficult problem to start with and you want to go backwards the other direction. So like one of them, I'm going to use one of those formulas up here. Sine of 25 degrees, cosine 5 degrees. We're going to go plus sine of 5, cosine 25. All right, now, I know this seems a little goofy, but let's say this is the start of your problem. And I don't know how you got there, and you know, you did some work in whatever problems you're working on, and you got to a point where this is where you're sitting. We don't have special triangles that have 5s and 25s in them. Like, we don't. There's two special triangles we have are 30, 60, 90s and 45, 45, 90s. So if you're at this point, what you can do is if you recognized it, this formula is the sine formula. It's actually doing this. It's sine of the first angle plus the second angle. Because if you can't recognize the formula, it's actually written right here. It's doing sine of the first angle, cosine of the second. Oops, sine of the first angle, cosine of the second, plus sine of the second, cosine of the first. Right? You can actually see that these are the numbers. This is alpha and betas in both parts. If you recognize that, you can actually go back. You can take this formula, which you have, and go back to the original one. You can simplify it down to a single trig function if this is what you have in one of your problems. Well, this problem, the whole thing, is this. It's sine of the two angles put together. The two angles they're using in this whole problem is 25 and 5. What you're looking at here, this whole thing, this part in red, is this problem. That's it. That's the entire problem.
Wait, could you just combine them and put 30?
Yeah, you're combining them down, going to sine of 30. And that's a simple number you can rattle off on a triangle. The most common mistake that people make is when you're in, Calc 2, and you're on these very complicated problems, you're simplifying, you're doing a lot of extra work, when you could have easily went backwards. You had a formula, you could have went back to what the original thing said, the original single trig function, and that's actually easier to do than the more complicated one. Because sometimes it's kind of beneficial to go back and forth between the two. You don't always have to separate them into bigger formulas. And the sine of 30, if you look at your special triangle, the special triangle is this, opposite, opposite, opposite. All right. So sine is opposite over hypotenuse. So the 30 degrees is 1 over 2. This is your answer on that problem. It's half. That's the sine of 30 degrees. Now, you have to remember Sohcahtoa, sine, opposite over hypotenuse, all that good stuff. Okay, there's a lot of talking going on. This is the first example I would like you to write down. We didn't do any of these on Monday where you went backwards the other direction. On Monday, I was always giving you very weird, obscure angles. I think we did like 75, we did 105. and we had to separate that into the actual formula, and then we solved this side of it. Well, now we can go backwards. You can take the complicated side and go back to the original angle, what it should have been, instead of separating. And it actually makes it easier. Okay, we're good?
No.
I'll wait there.
This is like the hardest chapter ever, but I'm so glad that you're a teacher for it.
Appreciate it. Alright. Okay, here's what I want to do. I want to go through a couple examples of normal problems. Not this whole thing going backwards and forwards. I want to do a couple problems where we start with, a single trig function where they give you some weird obscure angle. We have to go find it. And then what we'll try to do is we'll try to go into tangents today, and that's where we'll end. We're not getting homework or anything like that today. I'm not planning on it. My goal today was to practice this, have you try out a couple, because I only have you for about a half an hour or so. So I want to at least let you try a few problems out. Okay, but let's do one problem together right now. I want to try one of these. Let's do the cosine formula. I tried to bounce back and forth today. Let's do cosine. Okay, here we go. All right, cosine of 15 degrees. Cosine of 15. Now, 15 is not one of my special triangles. It's not the 30, 60, 90. It's not the 45, 45, 90. So I can't just, find a number, split in half. It doesn't work that way. Some people think, well, I'm doing 15. Just find the cosine of 30 and cut that answer in half. That's not how it works. Okay? Because you're picking half the angle. Cosine, when you do cosine, it's figuring out ratios of walls, and you cutting that thing in half isn't halving the wall. Okay? Because the 15 degrees doesn't tell you how long the walls are. It means that you have a 15-degree angle. These walls could be twice as long. They could be twice as long, or if they're not, maybe they're only 3/4 long. Because the angle doesn't tell you how long the walls need to be. That's what we need to be careful of. All right, questions before we start with what we're going to do here today. Does everyone have their property sheet out before we get going here?
Yes.
Okay, 15 degrees. If you turn to the side of your property sheet, can I borrow this bell? If you turn to the side of your property sheet, you need to look at the side with the big unit circle. The unit circle side will actually help you. You can use any of these angles on this unit circle. They either add or subtract to make 15. You can use any of these. So you can use, 315 and 300 for all I care.
Let's do 1645.
1645. We can pick any numbers you want, but they have to be on this property sheet. Okay? All right, so here we go. And I'm going to show you some shortcuts today as we go as well. So, cosine. Now, the numbers I heard, Josie, what were the numbers you wanted? 1645?
Yeah.
Okay, 60, and we're going to subtract 45 degrees. That will subtract give me 15, so that's a good combination. Again, I could have picked any combination I wanted. I could have went 150 and subtract 135, because those are on my property sheet. But, once I get to this point right here, okay, hey, shh. Gentleman in the corner, stop talking. Okay, good. Okay, once we get to this point, you've already committed to your angles you chose, and we already know what the trig function is. This cosine is this formula right here. Now, the cosine formula is actually the more difficult one out of the three. Sum and difference formulas. The reason why? It actually uses opposite signs in the formula. So what I mean by that is if we're going cosine of 60 minus 45, you actually have to add in the formula itself. Because when you subtract out front, you're actually adding in the formula. So let's actually write down the formula. So the formula is cosine of the first angle, cosine of the second, and now we're going to add sine of the first, sine of the second. And again, where I'm getting this formula from, it's from right here. When you have cosine with two angles either adding or subtracting together, this is the formula you have to use. It's cosine of the first, cosine of the second, plus now, sine of the first, sine of the second. of the two angles you chose. Okay, got a lot of people talking here for something we probably don't know how to do very well. Now, rattling off these answers, cosine of 60, cosine of 45, you have to use these triangles, and you have to know what Sohcahtoa stands for. So we're going to use the 30, 60, 90 triangle. The other triangle we have to use is the 45, 45, 90 triangle. So I have to put that one up here. You should have those on your property sheet somewhere. I'd almost recommend that you add these two to the side with the unit circle if you haven't already. You should have had those from the last chapter, but if you haven't already, you better have these two somewhere on that page. Okay. Now, in Sohcahtoa, when you're thinking about this little acronym, the letters help you set up what the walls are. Now, I will show you a shortcut here in a minute that will definitely help you out today, especially in the homework when we get there. But the goal today was to figure out where these answers come from before I just give you the shortcut right away. So cosine 60, cosine 45. These answers are fractions, and I need to figure out their answers individually by themselves. So cosine of 60, the first fraction I'm looking for. I find 60 degrees, and the cosine is doing this formula. So it's doing adjacent over hypotenuse. So adjacent of 60 is 1 over the hypotenuse, which is 2. So cosine of 60 is 1/2. Now why I picked 60 is because that's the angles we chose earlier. We picked 60 and 45 to be the numbers that made 15 for us. Now cosine of 45, doesn't matter which angle you pick, adjacent over hypotenuse, that's 1 over root 2, which I don't like to write 1 over root 2. I don't like to do that, so usually I just simplify it right away, or where I write this as root 2 over 2. Now, if you want me to, I can walk you through why it's root 2 over 2. You just multiply the top and bottom by root 2's and you simplify it. They don't like to have the radicals on the bottom. It's called rationalizing. You have to keep it on the top. Go to the next one, sine of 60. Sine of 60 now is doing the opposite over hypotenuse, so 60 degrees, opposite over hypotenuse, that's root 3 over 2. And the sine of 45, that's the same. Sine of 45 is opposite over hypotenuse, so it's 1 over root 2, which I'll simplify. Root 2 over 2. Now, that's where those numbers come from. Now, to prove that there is a shortcut, does everyone have their property sheet out in front of you?
Yeah.
Okay, you have the unit circle out in front of you.
Yeah.
In fact, I'm gonna flip to the unit circle here in a second just to show you what I'm talking about. I'm not done yet. I just want to show you how you can get to these answers without having to put a lot of mental effort into it. All right. So let me move this here. All right. So here's my big unit circle. Okay, whatever angles you chose. So in our case, we picked 60 and 45. So those are my numbers that I chose to make my 15 degrees. Okay, so what we're gonna do, I'm gonna zoom in here. I'm looking at the 60 and 45. These are my angles here on my unit circle. Right, those are the angles that I chose to use. These are the answers that we're going to be putting in those parentheses. Okay, what I mean by that is I told you earlier, and we had this on the last chapter test, cosine is always the first answer, sine is always the second answer at that specific angle. This is 60 degrees. This is the 45, so this would be cosine's answer, this would be the sine's answer. So you can actually rattle off the answers for your problems insanely fast, because when you look at for cosine of 60, you find 60 degrees, cosine is the first answer. So that's where I'm getting the half from as well.
Oh my goodness.
And then when you do cosine of 45, you pick the first one for cosine of 45. So that's why I can get these numbers really fast, because I just know my unit circle really well. Other than doing a special triangle every single time. Because some people get lost in that.
What did you study unit circle?
Yeah, I mean, that was something that I had to have when I was in high school. So.
Yeah, memorize that.
Yeah, we had to memorize the sheet you're looking at. We were not allowed to use it when I was in high school, so you had to have it all memorized.
That's insane.
Yeah.
How did view function?
Yeah, good enough. You just practice it enough.
How do you just like randomly practice that 60 is pi over 3?
You just know.
Just kind of remember.
Okay.
Mr. Ward, you should teach us how to remember that 60 is
Just takes practice, just to look at it over and over and
You should
over.
just not practice.
And I did a lot of homework too. A lot more than you guys did.
I do a lot of homework, Mr. Ward.
So, alright, let's keep going here. Last part. Hey, last part here, multiplying these together, this is root 2 over 4. This, multiplying this together, that's root 6 over 4, because again, you can multiply radicals together, you just can't add them. So when I need to add for my final answer, you're going to attempt to add the top, which you can't do because they're different radicals, but the bottom would stay the 4. This is the answer. I told you Monday, the answers for these problems when you do sines and cosines, the answers all look the same. Doesn't matter if the angles are different. It doesn't matter if you're picking weird, obscure ones. The answers will always kind of look some version, some form of the root 2, the root 6, and the 4. Because those are the only numbers I can choose from on this whole unit circle. Alright, now, the goal today was to give you guys a chance to practice this as well. Because this is something that you just need to see it, practice it, to see how to separate things, how to do it. So I'm going to give you one right now that I'd like you to try, and you can use your unit circle to help you out. So, here we go. I want you to find the sine of 195 degrees. 195. This can be any formula you like. It's either adding or subtracting, but you have to figure out a way to get to that answer. To get the exact answer for the sine of 195. So what you have to figure out first is on your unit circle, what angles are you going to use to make it either adding or subtracting. Once you have that chose, like your two numbers that you're going to either add or subtract, it could be any of these, on that unit circle, then you have to resort to your second page. You have to resort to your second page and figure out which formula you're going to use here. It should be one specific one. Which one you're going to use. Hopefully, you've been paying attention, you kind of know it. I'm going to walk around the room, I'm going to check. You should be able to just use your property sheet to figure this out very quickly. Your answer will look something probably like that in the end. Some version of that. But the work I'm looking for is written on the board. That should be something you're doing. Okay, I'll give you a few minutes to try this out. I want to walk around the room and see how you're doing it. Alright, hey, looking around the room, I'm actually insanely impressed that you guys are picking different numbers. That's really good. Now, let's try to iron out the details here. Okay, now some people picked 240 and 45. Some people picked 135 and 60. What was the ones over there? 150 and 45?
Yeah.
Okay, impressive, like different numbers. Now, I'm going to just pick one of them that I know worked, and then I'm going to get to a weird, completely different example that shows how difficult this problem could be if you chose different numbers than the 6 that you guys chose. Okay, so I'm going to just pick one of the numbers I saw a lot was 130. It was 135 and 60. Now, that's not offense to anyone else that picked different numbers than me. We all got the same answer anyway. Now, how this works. Once you're committed to two angles that either add or subtract to make 195, because some people picked 240 minus 45. Whatever this is, you have to use the sine formula to actually find it. And the sine formula here, depending how you do it, because we're finding the sine, right? You have to look at what your symbol is here. So if you're doing 240 minus 45, you're doing a slightly different formula than what I will do. Because since I'm adding, I'm doing the top addition thing. I'm using the top addition in the actual formula. So it narrows down which one you should pick. So now, how this works. If you look at the formula, it's sine of the first angle, cosine of the second, plus, since I'm doing a plus here, cosine of the first, sine of the second. And again, these can be flip-flopped, it doesn't matter where you wrote it. Questions on how I started that formula? No. Now, to rattle off the answers, it looks like a lot of you used your unit circles. Very nicely done. Sine of 135 should be a root 2 over 2 on your unit circle. 60, the square root of 60, the cosine of 60 should be 1/2.
Yeah.
Cosine of 135 should be a negative root 2 over 2. And then the sine of 60 should be root 3 over 2. And when you actually multiply these across, because again, I got those answers from your property sheet, we should get down to my final answer. If I multiply these together, that's root 2 over 4. If I multiply these together, that's a negative root 6 over 4, which is subtracting. And when you subtract straight across, here's what you get. Now, just to clarify something, you are not allowed to subtract the top. The reason why you're not allowed to subtract the top and write root 4, or negative root 4.
That's not how it works.
That's not how they work. When you add or subtract radicals, they have to be the same type of radical.
Are you serious?
So that's the only way that they add or subtract. Yep. You know, one of the examples I saw, somebody wrote negative root 4. They took the square root of root 4, which is 2, and then they had 2 over 4. Negative 2 over 4. That's not how that problem works. You can't actually do the math here. So you leave it. Again, as you can see, my answers are insanely close to what I said earlier. There's only select versions of what we're going to get from my answers. Now, as I said earlier, one person in the room, one person chose completely different numbers than anyone else. Okay? I want your numbers.
270 and 75.
Okay. They were not wrong. But let me get rid of this picture. And I want to talk about this problem because it was interesting. Yours would actually work. It's just way more difficult.
Let's see, there's no 75.
These are the numbers we chose. 270 was on the unit circle. 75 isn't. But you can still do this problem because here's how it works. You have to use the subtraction formula. And by the way, this is a problem you might want to write down. Because this would be something you'd see in like a college level pre-calc, write it down. Okay. When you do the subtraction formula for sine, it's sine of the first, cosine of the second, plus, actually that's subtraction, sine of the second, cosine of the first. Alright. Alright, there we go. Now, what makes this problem actually difficult, I don't know why I just put parentheses there. Parenthesis. Why this problem could be difficult? Because on the problem, 270, fine. You can look at your unit circle, you can rattle off what cosine and sine are for 270, they're nice numbers, or they're negatives or whatnot, or zeros. But 75 isn't. 75 is a problem you'd have to actually separate again. So if you're doing the sine of 270 times the cosine of 75, you'd actually have to split this 75 into numbers you've actually done before. And that's its own problem in the middle of this one. And then over here, this one, again, you'd have to split up sine of 45 plus 30 and do its own formula in the middle of what we're sitting in. So there would be a huge bracket here with a lot of stuff in there times the sine of 270.
You're at 40 and 35.
Oh, yeah, 40 plus 35 makes 75.
Oh,
And then you wrote 45 plus 30.
30.
What am I doing? I see what you're saying. Don't worry, I'm a moron. Just go with it. Alright. Alright, there you go. Thank you. Alright, I knew what I meant. I wrote it down. Alright, but anyways, when we get to here, I would actually have to write the brackets and do all the math for this thing by itself in a big bracket, which would be something that kind of looks like this, but right here, times this thing. And then this thing is also another one of these right here. You could technically do this. And this is what I was saying earlier on Monday. We can pick weird angles. Like one of the examples somebody said is like, can you do 12? Yeah, technically we could do 12, but you'd have to make it one of these where it's like in this endless loop of you breaking down number after number until you can make 12 out of a series of like 30s, 45s, and and doing other formulas mixed with these to make that. This is showing you the level of difficulty that you could see in a college level pre-calc and calc. Yeah. All right, last one today. This is my last problem to talk about. All right, last example I would like you to write down. I know we only got about a minute here. Okay, hey, last problem of the day. Hey, here's what I like you to write down. Tangent of 105. The tangent formula, no matter if we add or subtract, this is what it's going to look like. Now I'm going to pick 60 and 45. Those are the numbers we used last week. So if I'm going to do the tangent addition formula, this is how it works. You go tangent of the first plus tangent of the second over, that's a fraction, 1 minus tangent of the first times tangent of the second. So if you have an addition formula for adding and you're doing tangent, this is the formula you're going to have to use. You separate them. If it's subtraction, maybe you're going to do 135 minus 30 for tangent. Maybe that's what you thought of. Well, then your tangent formula will be this. 135 minus the tangent of 30. And then on the bottom, it'll be 1 plus tangent of the first, tangent of the second. Do you see the differences? If this minus sign is in here, it's the symbol on the top. If the plus sign's in here, that's the symbol on the top. The bottom will always be the opposite one. So if you're subtracting, you'll have subtraction on the top. If you're adding, you'll have addition on the top. The bottom formula will always be the opposite sign. Now, on Thursday, I'll show you where these formulas come from, the tangent ones. I'll try to show you that. That's it for today.
Yeah.
Stop.